Alright, hi you guys, and today in geometry we'll be talking about space figures and cross sections. Okay, so first off, space figures, let's start talking about what everything is. Okay, so vertex is actually the corner where all three sides meet. So let's say we're just dealing with a cube just to begin with. So vertex is actually this point right here. And as you can see, there's 1, 2, 3, 4, 5, 6, 7, 8 corners. So the amount of vertices on this object are actually going to be 8. Okay. All right. Now an edge is where both planes meet. I like to call it just not so much a corner. It's where two planes meet. And a vertex is where three planes meet, apparently, in this object. This one's a sharp corner. This one's more of like just an edge of an actual shape. Okay. And now if I count this one, okay. All right, let's make edges red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so edges will actually be 12. Right. Now a face is actually it's almost like a plane. It's like it's the flattest part of the actual shape. So the face is actually going to be stuff like in the front or on the side, you know, whatever you want to think of. And so in that case we actually have one in the front, one on the left, one on the right, one in the back, one on the top, and one on the bottom for a total of 6. Okay. Now, if you kind of notice something about this, all right, if I take the vertices and the faces and add those, I'm going to get 14, which is exactly 2 more than the edges. Well, guess what? You just recognized a famous formula done by Leonhard Euler back in Switzerland, which was any space figure that you can actually draw. Okay. You take the amount of faces plus vertices, okay, that will equal the edges plus 2. Or if you take the faces and add the vertices and then subtract the edges, you will get 2. So there's 2 different formulas you could use. All right. Now let's say I'm giving you, let's actually work with a really cool one. Let's work with a triangular pyramid. Now this would be called a triangular prism, but I also think it's called a tetrahedron, because it's just made out of triangles. Okay. All right, so what I'm going to do is I'm going to count up a couple of the sides, and then I'm going to guess what the other one is based upon this formula, and then confirm it by counting them. All right, so let's count the vertices. Okay, vertices 1, 2, 3, 4. Okay, so vertices is 4. All right, and then let's just count the edges. Well, let's just count the faces. 1, 2, 1 on the front, 1 on the right, 1 on the back left, 1 on the bottom. So that's faces. Okay, so that's a total of 4. All right. Now, so I'm going to use my formula. Vertices plus faces equals edges plus 2. Okay, so if I know that these two are going to be 4 plus 4, whoops, 4. Okay, and that's just going to turn into 8. Okay, then I subtract 2 from both sides, and I'm going to get edges to be 6. Okay, and if I count that real fast, obviously I could have counted it because I had the shape drawn out for me. 1, 2, 3, 4, 5, 6, and that actually confirms that number. Okay, but I actually used this formula to actually help me out. So Euler's formula is an amazing formula that you can use to work with this. Okay. Now, if we were actually in 2 dimensions, this formula is actually changed just a tiny bit. It still is face plus vertices equals edges, but it's going to be plus 1. So 2-dimensional shapes, like for example, if you're working with the net drawing and stuff, like let's say you took this apart and looked at the net, you would actually be using this formula, whereas if you put together the net, you would be using this formula. Alright, so now let's take a look at a triangular prism. Okay, this one kind of looks like those candies that you get at those really fancy Swiss candy shops. Okay, now what we're going to talk about next is cross sections. Okay, now cross section is where you're going to cut. You're going to actually cut it and then look at that actual shape. So you're going to cut out a thin slice of what's going on here. Okay, now for example, if I went straight up horizontal, oops, let's actually use a line. That's going to be pretty ugly. Alright, so let's go straight across here. If I cut it, okay, right across here, my actual cross section is actually going to be a rectangle. So a horizontal horizontal cross section is actually going to be a rectangle. Okay. Now a vertical cross section, obviously you can probably see it's going to be a triangle, but let's just confirm it. Okay. Go across here, boom. As you can see, a cross section is definitely going to be a triangle. Okay. Alright, so just working with that, let's redraw it because the green just disappeared. Okay. Alright. Now, if you want to change the angle of the cross section, you're going to get different shapes. And a great place to go to is Khan Academy. They actually have some great stuff on cross sections and just working with it. Like, for example, if I go diagonally from one end to the other, so if I go from here to this diagonal right here, I'm going to create an isosceles triangle, which is really kind of cool to actually look at. But, you know, like again, you're just going to be doing all kinds of cross sections, just working with all kinds of shapes on this, okay? Alright? Alright. That is pretty much it with cross sections. I will talk to you later. Have a great day. Bye.